subtraction and matrices. Given these three matrices, we will solve A plus B. So first, we will try to copy A, which is 1, negative 1, 5, 2, 2, 5, 3, 1, 5. Next is B. 2, 1, negative 1, 4, 2, 0, 6, 2, and 4. Let's add them together. So A plus B is equals to 1 plus 2 is equals to 3, negative 1 plus 1 is 0, 5 plus negative 1 is 4, positive 4, 2 plus 4 is 6, 2 plus 2, 4, 5 plus 0, 5, 3 plus 6, 9, 1 plus 2, 3, and 5 plus 4 is equals to 9. And that is the final answer.
So earlier we solved for A plus B. Now let's solve for B plus A. Where we can apply the commutative property. So first, let's copy 2, 1, negative 1, 4, 2, 0, 6, 2, 4. Plus, which is here. 1, negative 1, 5, 2, 2, 5, 3, 1, 5. So let's add them together. 2 plus 1, 1 plus negative 1, negative 1 plus 5, 4 plus 2, 2 plus 2, 0 plus 5, 6 plus 3, 2 plus 1, and 4 plus 5. So we got the answer. 2 plus 1 is 3. 1 plus negative 1 is equals to 0. Negative 1 plus 5 is equals to 4. 4 plus 2, 6. 2 plus 2 is 4. 0 plus 5 is 5. Next, 6 plus 3, 9. 2 plus 1, 3. And 4 plus 5, 9. So here is the answer, that B plus A.
Okay, so now we will subtract B from A. That is A minus B equals, that is 1 minus 2, negative 1 minus 1, 5 minus negative 1, 2 minus 4, 2 minus 2, 5 subtracts by 0, 3 minus 6, 1 minus 2, and 5 minus 4. So now we will subtract it one by one. So first is 1 minus 2. So 1 minus 2 is negative 1. Negative 1 minus 1 is negative 2. 5 minus negative 1 is positive 6. Next is 2 minus 4 is negative 2. minus 2 is 0. 5 minus 0 is 5. 3 minus 6 is negative 3. 1 minus 2 is negative 1. And 5 minus 4 is 1. So that's it. That is A minus B.
Okay, so moving on, we're going to solve number 4, which is adding matrix A to matrix C. So first, we write matrix A, 1, 1, 5, 2, 2, 5, 3, 1. And we copy matrix C, 1, 9, 2, 8, 10, 3, 7. So as you can see, we cannot add these two matrices because matrix A is a 3 by 3 matrix while matrix C is a 2 by 3 matrix. The rule for adding or subtracting matrices is that we can only add or subtract when these two matrices are the same dimension. Meaning, the answer, or there is no answer because we cannot add these two matrices. So the answer is cannot be solved.
Okay, so moving on, let's solve for negative 3a plus 2b. So in this one, first, let's substitute the values of matrix A and B to the equation. So we have negative 3, copy matrix A, 2, 5, 3, 1, 12. Then, add it to 2 times the matrix of B, 2, 1, negative 1, 4, 2, 0, 6, 2, 4. If you want, you can actually solve for this part first and this part first and then combine both matrices. But for me, I just substituted the value because it's easier for me. So let's apply scalar multiplication. So what is scalar multiplication? So basically, you just distribute this scalar value of negative 3 to each of the elements in the matrix. So we have negative 3 times the first number, 1. Then negative 3 times negative 1, negative 3 times 5, negative 3 times 2, negative 3 times 2, negative 3 times 5, negative 3 times 3, negative 3 times 1, negative 3 times 5. And you can solve it first. But I would like to continue here. Then, we also do the same to this part. We distribute the scalar value of 2 to each of the elements of the matrix. So we have 2 times 2, 2 times 1. Wait a minute. You write this. Okay? You have 2 times negative 1, 2 times 4, 2 times 2, 2 times 0. And lastly, for the last column, 2 times 6, 2 times 2, and 2 times 4. So we simplify it. We have negative 3, 3, negative 15, negative 6, it's too far, negative 6, negative 6, negative 15, we have negative 9, negative 3, negative 15, close. And for this part, we have 4, 2, negative 2, negative 2, 8, 4, 0. And lastly, we have 12, 4, and 8. So, this is the product of this matrix, and this is the product of this matrix. So now, first, before we can combine both matrices, we need to make sure that they have the same dimension. So let's count 1, 2, 3, 1, 2, 3. This is 3 by 3. In this part, 1, 2, 3, 1, 2, 3. This is also 3 by 3. which means we can combine both matrices. So let's just simply add the elements. We have negative 3 plus 4, 3 plus 2, simply copy, negative 15 plus negative 2. Don't forget to enclose it in parentheses so that you will not be confused later on. Next, negative 6 plus 8, negative 6 plus 4. Then we have negative 15 plus 0. And we have negative 9 plus 12, negative 3 plus 4, and lastly, negative 15 plus 8. Okay? And now, for the last step, combine it. We have 1, 5, 1, 5, negative 17. We have 2, negative 2, negative 15, 3, 1, and negative 7. That is negative EA plus. That's the outcome.
So now we will have another practice set. So let's try A minus B. So just like what we did in the previous examples, we copy 1 minus 1, negative 1, minus negative 1, 5 minus 5, 2 minus 2, 2 minus 2, 5 minus 5, and 3 minus 3, 1 minus 1, and 5 minus 1. So we post it to the bracket. So let's solve for this. So now, 1 minus 1, 0. Negative 1 minus negative 1, so that's double negative, so it's still 0. 5 minus 5, 0. 2 minus 2, 0. 2 minus 2, 0. 5 minus 5, 0. 3 minus 3, 0. 1 minus 1, 0. And 5 minus 1 is 0. Okay, so now we go with number 7. So in here, we are given 5A plus 5B. Okay, so first we substitute the values. 5, and let us copy 1, 2, 3, negative 1, 2, 1, 5, 5, 5. Plus 5, 6, 1, okay. So in here we will apply scalar multiplication as discussed earlier. So we simply multiply 5 in each of the values of the matrix. So first, we go 5 times 1. 5 times negative 1. 5 times 5. 5 times 2. 5 times 5. 5 times 2. 5 times 1. 5 times 5. Next, 5 times 2. 5 times 4. 5 times 4. 5 times negative 1. 5 times 4. 5 times 5 multiplied by 0. 5 multiplied by 6. 5 times 2. And finally 5 times 4. Okay, so we simply solve for that. 5 times 1 is 5. 5 times negative 1 is negative 5. 5 times 5, 25. Then 5 times 2 is 10. 5 times 2 again is 10. 5 times 5 will be 25. 5 times 3, 15. 5 times 1, 5. 5 times 5, 25. And then, don't forget the addition sign. And then, 5 times 2, 10. 5 times 1, 5. 5 times negative 1 is negative 5. 5 times 4, 20. 5 times 2, 10. 5 times 0 is 0. And 5 times 6, 30. 5 times 2, 10. And lastly, 5 times 4 is 20. And now, we are finally going to add them. So, we simply follow the instructions given earlier. So, 5 plus 10 is 15. Next, 10 plus 20 is 30. Next, 15 plus 30 is 45. Negative 5 plus 5 is 0. 10 plus 10 is 20. 5 plus 10 is 15. 25 plus negative 5 is 20. 25 plus 0 is 25. And lastly, 25 plus 20 is 45. And now we have our final answer. So to wrap up, we simply substituted the values and then we did scalar multiplication and we finally had.
So now let's proceed to the number 8, which is 5 times 8 plus 1. So in this situation, we should solve the matrix A plus matrix B first, and then we use the result to times 5. So let's copy it first. Here's the matrix A, here's the matrix B. When we're solving addition, we just simply use the A11 plus B11, A12 plus B12, so on and so forth. Also, A21 and plus B21. So we can get this. So 1 plus 2, 2 plus 4, plus 6. Negative 1 plus 1, 2 plus 2, 1 plus 2, 5 plus negative 1, 5 plus 3, 5 plus 4. In solving this, we will get 3, 0, 6, 5, 9. This will be our result for A plus matrix A plus matrix B. And then we use this one to times 5. So we will get 3 times 5. Also 0 times 5. And 4 times 5. 6 times 5. And 4 times 1. 5 times 5. And 9 times 5. 3 times 5. Also lastly, 9 times 5. And after we solve this, we will get 15, 30, 45, 15, 45. So this will be our final answer for 5 times 8, which is